So, continuing on with vectors and two-dimensional motion here. Can't mess around here. This is really foundational for a few chapters to come.
That's what they all say.
All right. Okay, you can often describe an object motion more conveniently by breaking a single vector down into its components. Here's what I mean. I have an x, y-axis here. I have a single vector. And I know that it's 50 meters per second. I could take that single vector and break it down into its x component or y component. Any two-dimensional motion has a certain portion that's going horizontal and a certain portion that's going vertical. Okay? So I can figure out the x component and the y component. Here's why that is important. What if I have two vectors? Like I change my direction here. Does that also have an x and y? It does. It has an x direct part of the motion and it has a y part of the motion. The reason why this is important is if I want to know the sum of these two vectors, which the displacement would be, kind of difficult to show this, but it would be like, assuming I did that pretty close to straight. Close enough. Do you see how I have an x part of this triangle and an x part of this triangle? If I add them together, what I get is a x total.
That's correct.
Here, I have a y1 and a y2. If I add them together, what do I get?
Y total.
A y total. So I have an x total and a y total. What do you notice?
A triangle.
A triangle.
Even if the line, or even if the slope isn't straight?
Slope is.
No, which slope? I don't know.
This drawing is
So,
not of these.
You're talking about this?
No, the blue line right above that.
Yeah, even at the blue line, yes. Because if I go from initial to final, that should be a straight point.
Because you
Straight line.
just, okay.
Yep. And so if I add the x's together, add the y's together, I should have a new triangle that describes the two vectors added together.
Which would be.
Okay? And we could add a third one. We could add a fourth one. We could add a fifth vector. Which we're not going to, but we could. Right?
What is a vector in life?
Victor.
What is it?
So a vector is used to describe something in reality. Like if I take a car and I drive down the street so fast in so much direction, I can describe the motion with an arrow. Okay? All right. Okay. This is kind of what I was showing you earlier. If they give you the whole hypotenuse side or a vector that is not on the x or y axis, you can break it down into its components only if you know the degrees of that angle. Here's why. SOHCAHTOA. That's not it. SOHCAHTOA. All right, so sine is opposite over hypotenuse. If you have the angle and you have the hypotenuse side, could you find the opposite?
Yes.
And with cosine, you have the angle, you have the hypotenuse, could you find the adjacent side? So with sine and cosine, you can break a vector up into an x component and a y component so that you can add them when you're doing a multiple vector problem.
Wow.
Okay? The point here is, guys, here's what this is saying. If the plane is going 95 kilometers per hour in this direction, there is a certain component of that that is just going horizontal, and there's a certain component of that that's just going vertical. It's just happening at the same time, and it looks like this. Okay? Because you have to have multiple forces. Otherwise, if you had just one force, you're just going to go in the direction of that one force. But if you have two forces, you can go not along the x or y axis. Yeah.
There's no ground.
Yeah.
Just a slope. We just kind of.
Alright, and so this is what this is saying. If you know the angle and you know the hypotenuse, you can break any two-dimensional vector up into its components, its x component and its y component, using beautiful geometry. Okay? This gets used more often than you know in the construction world, things like that. Very important when it comes to angles and finding things like that. Resolving vector. Do it. We'll see. We'll see. It could be crappy, but that's okay.
Why aren't they good? Always.
In many areas of physics, the necessary first step in solving a problem is finding the x and y components of a vector. Consider an airplane and its velocity during takeoff. How fast is it traveling with respect to the ground, and how fast is it rising in height above the ground? To find these two velocities, the trigonometric functions sine and cosine are used because the vector representing the plane's velocity is the hypotenuse of a right triangle. In this case, to find the x component of the velocity, the definition of cosine is used. The leg of the right triangle adjacent to the 20-degree angle is the x component of the airplane's velocity, which is its ground speed. Finding the y component requires use of the sine function. The leg of the right triangle opposite the 20-degree angle is the y velocity component, which is how fast the airplane is rising vertically. This example illustrates the general method of finding vector components using trigonometric functions and algebra.
Yeah, that was a good one, actually. I'm not gonna lie, I don't covet very often, but I was coveting that guy's voice.
What?
He had a
His
sweet
is
voice.
so annoying.
What? He had such a strong, low, powerful voice. Alright.
I come to cover this voice after the
So let me show you again here.
jealous.
I'm going to show you again here how we can get the big triangle when you've got two vectors. I'm going to do x in red, y in whatever that is, blue. Okay? So there's your x,
X1.
there's your y. Yeah, that would be y1, x1. Now, I'm going to do it, can I do it below just so it matches? What? Nice! So, do you see how this is starting here? And the x component of this? Actually, do you want me to do it up here?
Yes, it makes much sense here. No, Steven, shut up.
He's just finding that.
Basic property.
Okay?
Lord, you're ugly.
Whoa.
That's trippy. Sorry.
Steven, you're dumb. My God.
So there's y2. There's x2. If I take and add x1 and x2 together, this is what you get.
I don't believe it.
X total. And this would be, if you added the y's together, you would get y total. And if you take and connect the starting place with the ending, oh my God. It's very difficult to do, guys.
Just
I believe
it
you.
doesn't have to be done.
Why'd you just extract it like that?
Because I was so mad.
Hey, remember how I said don't let your emotions?
Negative
Neurons.
Oh, I told my cat neutrons last night.
Like
Negative
And he
neutrons?
said, your chemistry teacher said that? Oh no.
Please fix that.
It's a
Idiot.
neuron, isn't it?
Yes.
Like-
In your brain, axons,
Oh,
neurons.
Negative. This is probably what Shine does.
Goodness gracious. Your dad probably thinks I'm an awful
No, he
teacher.
was like, that's, I
you're
don't
awful
think that's
teacher.
right,
You're
Shane. He's
awful
like, you go tell your chemistry teacher that's not right. I was like, it's Kramer, it has to be right.
Please fix that. Text
I
it now,
will,
right now.
I will, okay.
Actually, she was on her phone.
Demerit. For falsifying my information? Maybe.
But that's
And
on her
you're
phone.
But that's lying too.
If you give it to kindergartners.
Alright, okay. Well, I guess they did it for me then. It's a little bit better.
time.
Yeah, wait. I didn't have to write it out.
Visual.
Visual concept.
That's good.
Oh, no.
Very, very important. The second problem's pretty difficult. So,
Wait, this is
Should we
very.
just do this
Those,
one?
you just want to do it on your own?
Do it. I want to
Just
math.
did
Wait, this isn't in our notepad.
It's not in your note packet?
Yes, it is.
Yes. Where I am so lost.
Okay, so here we go. This first one's pretty easy. It's just resolving vectors. It says find the components. Components means x and y, okay? Have I made myself clear what components mean when you see that?
X and
Yes.
Okay? You are traveling 95 degrees, 95 kilometers per hour at an angle of 35 degrees to the ground. When it says to the ground, it means above the ground.
North of
What?
east.
But,
When it says to the ground, I'm picturing it starting at the top and then going down.
no.
North of east.
Okay? So it wants to know the x,
It's that angle.
And it
to the
wants to
ground.
know the y component, and it gave us the angle of what?
35 degrees.
Which we can also find the other angle.
And we know
95.
that would really help.
No, we can't.
That would not.
You have a 90-degree angle.
I don't.
Okay?
That would not help.
So using SOHCAHTOA, SOHCAHTOA, or SO, the sine function, is opposite over hypotenuse. So you have sine of theta is opposite, which is y, and since it's velocity, we'll go vy. Okay, does that make sense? The y component of the velocity, vy, does that make sense?
Why are you using theta when you have your degree?
Well, I just haven't put it in.
34.
I'll put it in. I'll make it
Oh, you're making
Yeah.
the.
Are you some kind of
35.
wiggle?
There you go. Okay? And we know this is going to be our hypotenuse, which is 95. And so now you're just going to solve. You're going to get to the point now that you'll resolve so much of these vectors that you will just assume sine is going to be your Vy, which would be your 95 sine of 35. Why did I do that?
Is it inverse sine?
No, that's only when you're solving.
It's only when you're solving
We already
the
have the-
angle.
Oh, wait,
Just
never
do
mind.
You could, I suppose, but
That's easy.
it's pretty easy just to do the other way. What do you guys get?
I am
55.
55.
54.
I got 54.
Okay, so then we know that that's 54 kilometers per hour.
Should we use the angle to find the x, or should we just
only if it's
assume we
five.
can use the y value?
I think you get in the habit of using the sine and cosine functions because you're going to use them a lot. So then Vx would be 95 cosine of 35. Now, do you want me to actually show it out like I did here?
No, we can figure it out.
Okay.
Cosine.
So cosine is the adjacent, and so it's
So
essentially.
that's not a right triangle, so we can't.
It is.
use- So we can use Pythagorean theorem?
You could, but I think get in the habit of using the sine and cosine functions because you're going to need to get good at it. Could you use Pythagorean theorem? Absolutely, but
K per hour actually is the.
I'm telling you that'll hurt you later on, though, Autumn.
Not even a crush is a different thing.
You're a crunch, Isaac.
Thank you.
Do you know what crunch is?
All right. So here's what I would do. I would say this because it's a velocity. It needs a direction, right? What is it?
East.
And the other one's north.
I got 54.
He had his calculator in radians, and then he got
Questions on how to resolve one single vector? Could that vector go this way? Could you still do the same thing? What about this vector?
When did they do the other triangle? Oh, is this
What
one
other
just a single
triangle?
triangle?
This is just a yeah. This is just one single vector.
Hold on.
Okay. The next one will be a multiple vector problem.
Oh, no, never
Y is
mind.
north,
Never
X
mind.
is east.
But you did it in a different quadrant.
Then it would be south and west, or you know. So look at the context of what direction you're going, and decide what direction you're headed. Alright, next one. This one's gonna be a little trickier.
Well, weighted classes fix my GPA in other classes.
Why?
So I'm gonna have to donate all the hard work I do in my weighted classes to history.
$6
That's why I take
history and hours.
Oh, I didn't know that.
I do, it's speech.
Oh,
Okay, keep going.
Alright. So I'm gonna actually make this smaller so that I have more room. I'm gonna make a try to make this a visual picture. Okay. Let's see if we can do this. I'm gonna try to use multiple colors.
What?
Oh my word. Does this bother you?
That was pretty good, wasn't it?
Oh no, it's tilted. It's tilted like
That's the
that.
bottom line.
Okay, a hiker walks 27 kilometers from her base camp of 35 degrees south of east. Where is south of east?
South of east is
South.
quadrant
This
four.
is east, south of it.
Quadrant 4.
So 20.
It's right there, right there.
Yes.
I'm gonna make it longer just for.
I do everything with dotted lines.
Oh no, it's just.
Except for that one line.
Why did I? That's why I can picture it a little bit better for you. And we said this was 27
Yep.
kilometers, and we said this angle was what?
35.
I had to draw this out.
Now remember, my second vector better be tip to tail. So, we are going to go 41.0 kilometers in the direction north of east. So, if you're going to have a hard time figuring out where north of east is, for your frame of reference, make a little XY axis here. Everyone see that? Is this perpendicular parallel to this?
No.
And it's pretty close. If assuming yes. Sometimes I want to knock
Wait,
myself
is it supposed to be up and down straight?
Yeah.
Ignore the critics.
Thank you.
Lock up.
Because nothing matters in the end, so.
What happens when Cole gets a C+?
No, GPA doesn't matter.
Thank you. Thank you. All
I
right.
like moderate.
So now you see where the northeast quadrant is.
Yeah.
Okay? So I'm going to make this red. We got 41 kilometers, and it looks like this is probably going to go above the x-axis here. Because just the sheer distance and the angle's sharper. So something like
Doesn't
that.
it say you draw the scale?
I mean, I try to.
No, but like, in like, if we're doing it.
Not perfectly, no. I'd like you to get close. Because otherwise, if I want to draw this all the way up, then I'm sitting in the southeast quadrant, which that would mess up your direction.
Would it? Because you're still going the same way.
Your numbers would probably still work out, but yeah. Okay? So it's this angle here is what?
65 degrees is inside.
Remember, it's the angle is north of east. So north of east.
That's so garbage, I hate this.
Negative neurons, I mean negative neutrons.
Negative neutrons. Negative neutrons.
All right. Now, I need a green marker. Do I have one?
I have.
Yes! So, where is my resultant vector?
It's right across the top.
Final minus initial, or the difference between your initial and your final. So,
Straight
line.
Why'd you draw the 65 on the outside?
Because it's north of east of the graph.
north
Drew.
of east.
That's why I said.
Very important.
and then right
That's
after
why I
that,
said,
garbage.
draw yourself a little XY coordinate that agrees with the relationship of this XY coordinate.
I
At
did,
the end of every
but
arrow,
why?
you want to see.
I would. If it's a straight east and straight north, do you have to do that? No. But if it's at a really goofy angle, I would. Yes.
So when you're drawing your like second XY,
Uh-huh.
it's not right. Is it supposed to look like exactly the same as the first one?
Well, it should be, this X and this X should be
going to the
parallel.
origin? Like the.
No, this is not technically the origin. I moved the y over just so I could see it. But the point that you have to do is your x and your y have to be parallel. Does that make sense?
Yes.
Okay? So then, here's what I have to do. I'm going to get an x and a y of both my components. So here, I'm going to do it dotted just because it's going to look a little different. That would be my x1. This would be my y1.
Wait, why'd you do
Because that's the x component, the y component of that vector.
Because we want to write.
that? Is that one specific?
Yep, there's my right triangle. Okay? Now, notice how I kept my x and my y in the relationship of my angle. I didn't do it here and here.
What does that matter? Does that matter?
It does, because you would need this angle then, if you were going to do here and here. So I cannot do here and here, I need to do in the angle.
Well, oh, I guess we did get.
I know that's not perfectly vertical.
Buttery biscuit, please.
So point two.
X2, Y2.
Makes sense.
Now notice,
Yeah, right.
I want you to just, that's bad, but that's okay. If I take my x1 and my x2 and add them together, do I get the whole x that would start making the bottom part of the big or my final triangle?
Yeah.
And if I take my y1 and my y2, I'd have to subtract out the y1 from this because it's negative. And wouldn't I just be left with this part?
Yes.
Doesn't that give me my full x
Yes.
and my full y?
How
You
do you
see
know
it?
if that's the triangle you're trying to make?
Because this is my resultant, this is what I want.
Oh.
And this,
Oh.
in order to get this, I gotta know the x's and the y's.
So just solve for both.
Okay.
We got 3 minutes, let's do the math.
Oh my word. I don't want to do this.
Okay, I'm gonna do with my nice, I'm gonna do with class. Let's start with the x and y of the first guy. So, if I'm finding opposite, is that sine or cosine?
Cosine. Or sine.
Sine.
Yeah.
Okay, so y1 would be 27 sine of 35. Everyone see how I did that?
No. Yeah.
27 is hypotenuse,
Oh, sorry, I thought this was
angle, opposite.
Yep.
x1 would be 27 cosine of 35.
So which do you go to this?
Don't do sig figs till the very end.
Okay.
Okay? Now I'll use a different marker for the next
Yeah, I
one.
was wondering if you just discard the degrees above us.
Alright, we're starting here. Opposite is y, so we're still sine, right? But now our hypotenuse is different, correct?
Yeah.
41 sine, and my angle's different.
65.
And then my x2 should be 41 cosine of 65.
Will sine and y always be together?
Most of the time, but not always.
So how do you put on the negative one?
Because if Cheyenne, let me explain. If this is what I was doing,
Yeah.
then now my opposite is x.
Okay.
You see it?
Yeah.
All right. I'll just give you the numbers of these quickly. Ooh.
Oh wait, I got the numbers if you need.
Okay, there's 2 ways of doing this. What did you get when you did 27 cosine of 35?
22.
22? What did you do when you did sine? 15. Okay, this is really important. You either have to put in the negative angles or you have to look at it at the end and figure out direction. Because technically this is a negative angle, isn't it?
Yeah.
It's below x. However, if you just plug it in as positive, it'll give you the right magnitude. But notice, what's my y here? Negative. So when you're doing this, when you put it in here, you said the y was what? 15 something?
15.5.
So it needs to be negative. The calculator won't give it to you unless you put in a negative 35.
Okay.
Okay? And what is x?
22.
22.12.
Oh, what?
Negative. Not negative, it's positive. It's a positive x. Okay, your y. Is a positive x and a positive y?
Yeah.
So it should be positive numbers. What do we got? X is 17. And y is 37. Okay, to finish, we need an x total and a y total, because this gives me the parts that I need for Pythagorean theorem. Add them together. My x is x, which should give me 39. Alright? And my y, one's negative, so it should give me approximately 21.5.
Oh, so you discard the negative?
Well, no, I don't discard it. I'm subtracting it. Stop, please. Now what will we do? Pythagorean theorem. To get, we have this, we have this. Pythagorean theorem gets me this. Everyone see it?
Yeah.
When you do Pythagorean theorem, the square root of 35 squared plus 21.5 squared, you should get about 45. So that is my magnitude, but what am I missing? Direction. What? And direction. Okay? So how do we find direction then? It's this angle, right? We have the x and the y. Every time we do angle, or every time we find angle, it's inverse what? So angle is tangent to the -1 of what was my opposite and my adjacent. It should be the total. Opposite's 21. Adjacent's 35 or 39. Your angle now should be 29 degrees.
Wait, couldn't you use the inverse value?
You could, I think. Now let me cap this off by what your final answer should look like. Your final answer should be 45 kilometers at 29 degrees, but I need to be specific. North of east.
Wow. That's one. Could you leave out the means?
Sorry, what? Yeah, you can leave out the.